Good morning, grade 11. Hopefully, you're all keeping up with the work. I'm trying not to set too much for you guys. Obviously, the news with looking like we're going to be in this for a fair while. So I'm sort of working towards creating your next assessment task so I can give you guys sort of 4 weeks or so, 5 weeks or so to work on that. It will count for quarter four, but that's just an update on that. It will be another project of sorts, hopefully with a lot of options for you guys to choose your own activities and things that interest you based upon this topic. So today what I'm going to do is I'm going to talk about the immune system. So we've just talked about this a little bit at first when we've just sort of gone over the history and all that sort of stuff. So what we'll talk about today is we'll actually talk about the two types of immune systems and a couple of the words for that. So what I like to call them is the specific immune system and the non-specific immune system. So let's start. We're going to start with the non-specific immune system. And it involves the first two layers of defense, layer of defense number one and number two. So I always like to think about it in terms of a castle. So here's a castle here like this. How would you invade a castle? I'll just stop and let you think about that for a little bit. Like what were the medieval techniques that we used to invade a castle? Well, for me, I always think about like lots of soldiers. I sort of think about like Lord of the Rings and like big catapults and trebuchets, and then I think about lots and lots of soldiers manning the top here of the masts, and then up here on the towers, and you've got people shooting out arrows. And really, the whole thing of a castle is it's a fortified defense. You don't want anyone to get inside the castle. And once the walls are breached, then usually the castle can fall pretty quickly. So really, the first things first is, well, just looking at this castle here is, well, what layers of defense does it have? And it's obviously got this nice big moat around it, and it's also got a really strong walled system. So usually they've got some nice big strong gate out here as well. It's hard to tell from this picture, but that's another one as well. And really, this is analogous to your first layer of defense. Basically, the wall of the castle is the skin of your body. It's going to try and stop most pathogens from entering your body. I like to think of the pool and the moat around it as the mucous membrane. That is, the areas in your nasal cavity, in your throat, in your reproductive organs that mean germs cannot get in there. And they're usually a pretty good layer of defense. So the first layer of defense there is usually our skin, which is going to be the castle walls, and the mucous membranes, which is going to be our moat. Brains, which is our moat. And that's really the first layer of defense. Nothing overly complex there. You guys have done work on that already. Now, the second one there is the non-specific, is part of our next one, we said non-specific. And I'll color the non-specific one here in red, and I'll leave the third layer in a nice blue color here. Now, what we're going to have with the second layer of defense is, well, okay, let's say, for instance, that we've had some soldiers that have managed to wade across our moat, and they're bringing up some of the siege machines or siege weapons to try and get into the castle. So you might think of those as ladders. And what are the defenses against that? Well, in medieval times, they used to pour down hot, boiling tar. I actually read when I was in Oman that they used to pour hot date sauce in some of those Omani forts on top of people and kill them. They had fire traps, booby traps, and really the whole idea was the soldiers manning the outside was to stop anybody from getting inside. If there was a battering ram that might come in towards the gate, then they would seal the gate shut and provide as much support behind that gate as physically possible. So your second layer of defense is your soldiers. And what your soldiers will do is they'll defend the outside of the castle, but what will happen is that if someone, let's say, for instance, that one of the ladders is successful. Let's look at this tower here at the front. Let's say some soldiers have managed to enter there, and they're coming up and they're swarming across the ladder here and they're climbing onto this tower. what are the soldiers on the inside of the castle going to do? They're going to rush there. They're going to rush there in order to try and defeat that soldier. So really, that's very similar to what happens in your body. And in fact, your soldiers pretty much perform exactly like white blood cells. So when there is an infection in your body, white blood cells will rush there, and you'll notice that. The area will become inflamed, and often as well, another side effect is fever, as your body's trying to stay warm as well, to try and provide conditions that aren't good for those incoming soldiers. So they'll rush that area in order to try and clear away any soldiers that have entered into that broach, that one area of the castle. And if they have success, they'll be able to throw them off, and then that's it. They can then disperse again. Now, what they would do is they would probably learn something from that experience, and they would, well, okay, my opposition is going to try and climb a ladder here, and basically we'll try and climb the ladder and try and get up into the top here. So maybe next time they bring out more crossbowmen or archers to try and shoot down the people who are climbing up the ladder. And what that is that's something called an antigen. It creates, when those white blood cells come there and engulf and defeat the enemy, it leaves behind a bit of a memory of those enemy. And that memory is an antigen. And antigens are going to become really important when we talk about our third layer of defense. Okay, so let's talk about the third layer of defense. I'll just drag this up. The third layer of defense is what we call our specific immunity. So again, red was non-specific, and the third layer is our specific immunity. Now, the thing is about a castle is that generally you can get beaten pretty easily if you have a significant outnumbering in opposition. So if you've got 100 people defending a castle, that's fine. But what's happening as well is that the people inside the castle are the people you're trying to protect. They're the vulnerable women, children, old people. So what the castle does is basically, eventually, it's going to use all its resources. Unless they can find a way to tunnel in and out of there and be able to get some things out of there, then really you're going to starve. And that was what medieval battle was often all about. It's called siege warfare, in terms of you crowd all around that castle, make sure they can't leave, and you basically starve them to death. And that was really common in a lot of historical battles. So what have you got to do if you're inside this castle? Espionage. You have to send out some spies. You have to work out how the opposition is going to try and defeat you. So your spies are going to go out and, well, all right, maybe we need to take down some of these siege machines that might be able to come in and break down our doors. And really, that's what your third layer of defense is. It tries to work out the opposition tactics before they can even strike. And then when they do come close to the walls, they know how to dismantle them. But we'll talk about the specific immune system in another lesson. So let's get on with this. So if I go down here, here's my first line of defense, as I've told you, is the skin. And if I move down here, this is what the inflammatory response looks like. So if we have a problem, so here's the problem, there's some cutting on the legs here, then what a chemical called histamine is going to give us that inflammatory response and basically is going to rush more fluids towards the wound. As I mentioned to you, that is usually involved with more white blood cells coming towards the wound. We're talking about our castle. That was where the soldiers were rushing to the area where the castle had been breached. You also, as I said there, in terms of a fever, because many pathogens have a specific temperature window. And that's where my castle analogy probably falls down a little bit. I can't really explain that one with it. But as I said to you, right, most pathogens usually thrive at that 37 degrees Celsius range. And by heating your body up, you can actually somehow also get those pathogens to not function as well. It's the same thing with enzymatic activity that we looked at earlier. It had that peak threshold at 37, and then after 37, we saw a pretty steep decrease as the enzymes began to denature. Your body is pretty well organized through millions of years of evolution to work well at 37 degrees Celsius. Okay, so what are these white blood cells and what can we divide them up into? really, we can talk about two different, there's all of these different white blood cells. I'm going to try and keep it simple for you in terms of the white blood cells. But really, we have two types, and that is monocular, so the nucleus is in one piece, and then granular, which is nucleus is in multiple pieces. So just some of the ones that we'll be talking about in a little bit more detail is probably the basophil and the lymphocytes. So the first one, and the one that's really important, are the second layer of defense. Those big, dumb soldiers that are going to come and rush the bad guys, they're called phagocytes. Okay? So phagocytes are basically, and here's a picture of one eating some bacteria here, they are white blood cells that are going to come and engulf the foreign pathogen. Okay? So I'll show you what that looks like in a little bit. And what they'll leave behind is they'll leave behind a little antigen. Now, the analogy that I like to use when I talk about that is actually Pac-Man. And here we are here on Google. We've got the Pac-Man doodle happening. And really, pretend that Pac-Man here is my white blood cell. Now, we've all played Pac-Man before. But really, what happens is, when I get one of these little fruit here, is that I can now go and chase down the ghost. Now you'll notice there, the thing I like about this analogy is that once you, oh no, I missed him. Get him. No! I'm doing really badly here. It's hard to talk and concentrate on this at the same time. As you can see there, once I've taken down that ghost, I've really just left behind. You see those little eyes that run away? I like to think of them as an antigen. That's the memory that the ghost existed. So really, this thing here is the phagocyte. Pac-Man is the phagocyte, and he's trying. First of all, the analogy doesn't work because he's originally running away from the ghosts. But then once that he has these little things here, then he's chasing down those bad guys, the pathogens. He eats them. And then he basically leaves behind a little bit of leftover antigen, a memory that cell actually came in. Now, the other thing that we need to know there is basically what you're going to look at. And this is where I'll give you guys a chance. You can sort of piece this together. And I've put it together a document that asks you what you're going to work on today. There's multiple animations of what it looks like, both in the cellular way and in an animation. So I want you to look at that today as well, and you guys are going to try and piece together just a simple comic strip or a simple little interactive about how that interaction actually works and why it's important. So back to my slides here. I don't think there's anything else we really need to talk about today in terms of your immune system. The only other thing that I will mention is that, I missed it. Is that yeah? So you have your phagocytes that have taken that thing, taken them down, and then what am I trying to? Where else? Damn it! I've missed it. Vaccines, lymphatic system, B cells. Killer cells, we'll learn all about them next period. Helper T cells, we learn all about them next period. Antibodies, that'll be all next period. But yeah, I think that's going to be basically about it. Where was that slide on the immune system? What have I done with it? It's disappeared on me. Here we go. So, the final thing that I'll leave you with, sorry about that, guys, was that there's two types of immune system. So as I said to you, the first one is the non-specific immune system, and that is just going to fight any pathogen that enters your body, okay? It's not going to be specific. It's not going to remember anything. It's just going to be your body's response to any pathogen that enters the body. The specific immune system, as I said there, involves a lot more different types of cells. It's a little bit more complicated. We'll look at that later on in a period next week. And as it says here, you are not born with the adaptive immune system. This is your body building this immune system over time. Because these antigens that are left behind, what they do is they enable your body to build antibodies to be able to mark those antigens so that other cells can come and destroy them. Okay? So we will talk about that much more next period. But for today, we're focusing on that second layer of defense to your immune system. Thanks for your time. Hoping to live chat with you all soon. Adios.